Hi, this is Mr. Gomez here. This is a short video to help you see how we were supposed to solve for practice number 4. I looked at a lot of your homework and I saw some good things, and I did see some things that you need some help on, okay? So hopefully by seeing this video, you're able to better understand percent yield, and more than anything, better understand how to convert and do stoichiometry, okay? So let's take a look at this problem, okay? In a reaction between 1.25 grams of KCl and 2 grams of AgNO3, a mass of 2.37 grams of AgCl is recovered. What is the percent yield for this reaction? So the first step that I always want us to do is to write the equation for percent yield, right? So that we know what we need to do to solve for it, okay? So we do Py equals AY over TY times 1,000, okay? And then the second step that I have you do is to actually replace AY for the actual yield that's given to us in the question, okay? So if we look at this question, what do you think the actual yield is, okay? Just going to give you a couple of seconds to answer that question, okay? The answer is 2.37 grams of AgCl, and the key word is recovered, okay? So when you look at this chemical equation right here that I just underlined, okay? Look at that chemical equation. Okay, somebody actually did a reaction between KCl and then the second reactant, and then they recovered a mass of 2.37 grams. So that's what actually was produced, okay? So the actual yield, and we're going to replace it in step number 2, percent yield equals 2.37 grams over TY times 100. Let me tell you where many of you got tripped up was actually in this step. Not because you got 2.37 wrong, but because you forgot to put 2.37 at the end of solving the problem. You forgot that this was actually the actual yield, okay? And you replaced it with 1.25 grams of KCl. So just remember to always put the actual yield on top and to not forget it, okay? Have it handy, okay? Step 3, we're going to solve for the theoretical yield. So we just wrote down what the actual yield is. The actual yield is what actually took place in the chemical equation when somebody perform the chemical reaction, okay? The theoretical yield is what should have been produced, okay? That's why we're always going to solve for the product, okay? In this case, the product is AgCl. So that's just one more reminder of what theoretical yield is. If we're talking about food, right? Let's say you bought 2 buns, you bought 10 buns, 5 burger patties, right? So technically you're supposed to make, if you have 10 buns and 5 burger patties, you're supposed to make 5 hamburgers, right? Well, let's say you're preparing the meal and you drop one of the burger patties on the floor, right? And it gets in the dirt. Well, you're not going to be able to use that, right? So you're only going to be able to make 4 hamburgers now because you only have 4 patties, right? So that was the actual yield. But the theoretical yield is what should have been made, which was 5 burgers. So kind of just telling you the difference, okay? So the theoretical yield is how much AgCl should have been recovered. So let's go ahead and take a look at this. So in order to do this, I can actually pick any one of the reactants, and I'm going to go ahead and pick the 1.25 grams of KCl, potassium chloride, okay? So we're going to go from grams, we're going to go from 1.25 grams of potassium, which is K, chloride, and we're trying to go to grams of AgCl. Okay, that's going to be how we're going to get to the theoretical yield, okay? So many of you are messing up on that, okay? So let's go ahead and do the conversion. We're going to go from grams to grams, okay? So our given is 1.25, okay, grams of potassium chloride, okay? So our given is always going to be box number 1. So I'm going to put box number 1 is going to be our given, okay? Box number 2 is going to be grams of A to moles of A, okay? And let me write that out because you guys tend to copy every single thing that I write out. Okay, so we're going to go from grams of K potassium chloride to moles of potassium chloride, okay? So for every 1 mole of potassium chloride, how much does it weigh? So in order to find out what's going to go on the bottom box, you're going to go to the periodic table of the elements, and you're going to figure out how much this weighs, and it's actually 74. Okay, it's 74.55 grams, okay? Notice how grams of KLCl are the same on the bottom box. They're going to end up canceling each other out, okay? Box number 3 is going to be moles of A to moles of B. Okay, so on the bottom box, we're going to write we're going to go from moles of KCl, potassium chloride, to moles. Remember, we're trying to get to AgCl, right? So that's what we're going to put down. Many of you kind of tripped up on, okay, I don't know what substance goes on top. Okay, so we're going to get the numbers that go in these boxes, we're going to get them from the molar ratio. Okay? And we get these numbers from the coefficients in front of these substances in the chemical equation. So the number in front of KLCl in this chemical equation, there is no number in front of it, so it's a 1. If you look at AgCl on the chemical equation, there is no number in front of it, so it's a 1 as well. Our last box in our conversion is going to be, the 4th box is going to be moles of B to grams of B. Okay? Notice how moles of KCl are the exact same thing, okay? So, oh, what just happened? Okay? Holy cow. Oh, I was like, I accidentally went to the next page, okay? So in the last box, we're going to have moles of AgCl to grams of AgCl, okay? Notice how it's the exact same thing, okay? So for every 1 mole of AgCl, how much does it weigh? And once again, we're going to go to the periodic table of the elements to let us know what this molar mass is. And it's going to be 143.32. So now we're ready to solve for this. So we're going to multiply everything across on top and divide it by everything on the bottom multiplied across, okay? So on the top, you have 1.25 times 1 times 1 times 143.32. You have 179.15. On the bottom, you're going to have 74.55 times 1 times 1. So number times itself times 1. A number times 1 is always that number. So we have 179.15 divided by 74.55, and you get 2. The answer is going to be 2.4 grams of AgCl. This is going to be our theoretical yield. Now, well, let me ask you a question. Have we solved the problem? No. We've only solved for the theoretical yield. Remember, we're trying to solve for percent yield. So we need to go back to step 2, which I'm going to put a star right here if you can see it. I put 3 stars. So now where it says TY, we can fill in the blank right here and complete the problem. It's very important that you remember step 2 because many of you were forgetting that 2.37 was the actual yield. When you solved for the theoretical yield down here on the bottom, you rewrote percent yield and then you mistakenly picked one of these numbers on top. Now you know why I had you do step number 2. So percent yield, I'm going to do this on the bottom left, equals, okay, 2.37, okay, over the theoretical yield that we just actually solved times 100. Now, let me calculate this. So we're going to do 2.37. Teachers have to do calculations too, just so you know. So we get 0.98 times 100 will get us 98.75%. Okay, that is the percent yield. And I hope that this actually helped many of you that were having problems understanding it.